Hi, recently I have released an exclusive Raspberry Pi packet generator. So this is going to work out of box. All you need to do is you can just download the Raspberry OS, which it contains the pre-installed Raspberry Pi network packet generator. So this is an extremely versatile tool. If you are a student, if you are working in network software development, if you are doing some R&D, or you are doing some sort of ethical hacking and stuff like that, so please check it out. I have done an extensive video episode on the same. It is very easy to install and very easy to try it out, and unlike x86, it just works in the standard Raspberry Pi hardware, so there is no change in terms of the hardware. It is just going to work out of box. Just take the image, extract it and flash it on a micro SD card and it is good to go. So you can go through this video so that you get all the steps involved in terms of using such a tool. I'm going to link this page in the video description, so if you're interested, follow this link and then you can get Raspberry Pi packet generator. So let's get into the episode. Hi, welcome to the show. So we start this episode with an interesting comment which I got it for this video. See, recently I shot a few video series on Raspberry Pi GPIO pin access in the context of kernel's CFS interface. See, this is nothing to do with the GPIO setting up the LEDs and stuff. This is purely in the point of view of systems. I shot this episode. I was just mentioning the role of CFS file system. Just like a proc, CFS gives an access of kernel modules which you architect. You can provide an access to these kernel modules via CFS file system access. See, this is a pseudo file system or sort of a virtual file system. Hence, since it's a virtual file system, you get the file system mounted as you start the driver, and once the kernel is booted and once the kernel is shut down, there is no files per se which exists on the hard drive or something. So it's a complete virtual file system. Hence, you can see there I got an interesting comment. So you can see there from a viewer called Jack Winch. He was mentioning about an interesting aspect. See, he is telling the CFS where is that? Yeah, is now depreciated. There is a it's technically called as a feature getting depreciated or something in even in kernel forums or kernel code check-ins. Generally some may comment saying that this has been depreciated, which means it's kind of outdated or getting phased out. Okay, that's what it meant. So he's saying that it is getting depreciated, and he also points out to an interesting link. You can see there from kernel.org. It is a part of the documentation of official kernel.org. So if this is going to be here, you should able to find the same thing even in kernel source as well. So many don't know, if you access the kernel source, where is that, yeah, kernel source, you go inside, you should find it in the doc folder. So somewhere you can you will be finding the same documentation. So that's what is the link he pointed out, and it kind of lists few aspects. So I thought I can discuss a bit on the character drivers, because you can see there, of course, after he commented, I just sent a reply saying that that is fantastic, and it is indeed very interesting, because I said, see, unlike you access sysfs or proc fs file system, the problem with such a file system, apart from the advantages, and as I long back mentioned, I myself is a fan of proc file system. So you can see the episodes over here, proc interface. See, of course, I often point out this series, because in a way you can use this for multiple use cases. So even here I was mentioning that this is my favorite interface. The reason is, if you expose the features, the driver features or configuration through proc interface, you can access the proc interface through any user space platform. So it can be, let it be Java applications, let it be C++, whatever it is. Okay, so you can use any scripting languages, you can use regular C or C++ code, and then you can access, because these are treated like regular files. So this is one advantage is there, but the disadvantage is, as you access these as regular files, the disadvantage is each time you need to set a value, you need to read a value, then you need to do a read write access. Before that you need to do a file open. Okay, so if you write a C code, you need to do fopen and stuff, but if you write some scripting languages, you don't need to do that, because you get more powerful abstract APIs. See, for instance, in PHP we get something like get file contents, something like that, and PHP, if I type, see, you will find an powerful API like this. So here, if you use this API, it's a single API, you see there, echo, and then doing that get file contents. Okay, file get contents. Okay, so what you can do is, if you have such powerful API, when you do coding, when you do code, what you do is, you can literally do like this. See, you can have a PHP variable file dump. Okay, and then you can do that file underscore get contents, like that, and you can mention any file. In this case, we can even mention that proc file. Okay, proc say CPU info or something. You can put any proc file or your own drivers proc file access. So you do that, what happens is, you can get the contents. But even you do with an abstract API like this, internally it is doing still that fopen, fclose, and it is doing the read operation. So here it is abstracted with this type of API, but if you do in C or C++, you need to use all that low level file access APIs anyway. So that's what happens if you get an access via proc. Hence I mentioned, see, unlike that, I can able to understand its true potential, because if you are resetting and setting these kernel values via proc interface, okay, the whole purpose of using such an interface, proc or sysfs, let it be anything, is to provide an access to your kernel modules or drivers, whatever you do in the kernel space. So if you have some global variable and it is having some sensitive information, then you provide a proc interface or sysfs or IO control, any such interface, and then you can access that parameters. Hence we have that access. So I mentioned that, see, we don't need to do that if you have something like a character driver. So that's what is his whole comment is. See, you can see there he says, and he says that there are other abstract APIs are available like this libgpiod and stuff. You can see their accompanying library. Hence, if you go through this, they mention, there is a mention about this character driver. See, this will appear as dev GPIO chip 0 and so, and it is a form of character device. Okay, so this is like a character driver. So The advantage here is it will be like any typical character driver access from user space. The advantage is you do once open, and after that you can do any number of times read and write operation. So that's the main advantage of doing something like this and phasing out the CFS access, which is what this comment is all about from the viewer called Jack. Okay, this is why I appreciate comments like this. As I say often in my videos, I am not looking for any feedback. I actively work in the industry. I am not looking for any much feedback. What I am looking is, if you have interesting Q&A, or if you need to discuss something very interesting, okay, you can discuss in mail also, or you can discuss in comments like this. It's just not if you are looking for questions, it's just not only answering your questions, but sometimes it may be in an interesting use case we can discuss in video episodes like this. It is a small thing. If you are a beginner, you don't understand much about this, you learn something like kernel programming, and then somewhere you find that, okay, driver coding, I get lot of jobs. Okay, you go there and you learn some character drivers and stuff. This is a beginner stuff. But if you are an architect, each one word carries a lot of weightage. There can be advantages by moving towards a different approach and see the implications and stuff. So it is each thing what it catches my attention. It depends on the situational basis. So this caught my attention. I thought I need to take a interesting video episode like this. See, which is why I'm saying go here and search as character drivers or something. Character driver sample kernel programming. See, we take some example which is in an online source. So we take some few examples like this. So you can take anything, and of course even LDD book has their own example. So you can take anything like this. This is from EPCAR, I guess. This is quite popular, and indeed when I take sessions with my students, I do discuss about this EPCAR driver. So nothing secret about. See, we are not picking any free stuff from online. When you need to do any character devices, you need to more or less use the same thing. There is nothing much changes. Maybe you may use your own names, API names, but rest it is the same. You just need to use whatever is provided APIs, and then you get that service from Linux kernel. So hence it is a good example. Even here you can see there you get where is this module init. Go to the module init, you will find init EPCAR init, and you will find this register char dev and then device name and stuff. So they do that, and then you have this supplied APIs to do read write operations. So you can see there dev read, dev write. These are the callbacks of respected read write operations. So if you scroll down, you get the support for that read write stuff. And if you scroll down, they have provided one user space application to test the kernel's service, which is through character drivers. Okay, first I am saying you, if you are a beginner, don't get into this confusion of learning about what a character driver, what a what a block driver, and some you will find lot of differences and all that bullshit. I am saying one thing is, anytime you hear a word, first see that where and all is its applications, why such a thing is there, and what is its limitations, and why you use, and you write your own code and see that where it helps you. So learn in this aspect rather than going through some sort of a useless theory which you will find often in a college academics. Okay, I am saying anytime you see this, see that where is its real use case, where it can be sort of applied and stuff. So it can be indirectly used. This architecture, you can indirectly use it to support a GPIO type of driver interface. So the upper part of the GPIO driver, I am not saying this is the lower part of the GPIO driver where it actually interacts with the GPIO hardware itself. Okay, some controller or something. Okay, it will interact with the hardware itself, but in order to control the GPIO drivers, okay, to turn the LED, turn the pin on, off, or if it is analog, maybe some voltage range, do something like that. The advantage of using a character driver is, as you can see there, this is the sample user space code. You see there it has this main, so it is a sample user space code. They are doing a test read and then they are closing off, but you can actually do any number of times read, and this is going to work just like sockets. okay, you can do read any number of times, you can do write any number of times. So just like sockets, it is going to work, which means it is going to work more like a streaming service. Okay, I'm not saying internet streaming, I'm saying about when you do sockets, you can treat it like a streaming channel. Okay, you can keep writing through the channel without closing and opening each time you do read write operation. So same thing you can do with something like this. Hence, in fact, this week I'm going to discuss with one of my student about how you can use this as a sort of a different IPC and use this sort of an architecture. So again, I'm saying as an architect, I do approach things in a different way, because we can have our own stuff, we can put our own platform and stuff. This is quite common, as this is a part of my regular workflow. Hence I'm saying what the comment meant is, when they adopt to character drivers, the immediate advantage you get is you don't need to treat it like a file. When you don't treat it like a file, then what happens is you don't need to read and write each time by doing fopen, fclose, and then followed by in between read and write operation. When you do this thing for files, see, in a file you can't do constantly read operation. It is a finite content is going to have. So the moment you do read, the contents is fully read, you reached file, end of file stuff, and then the file read is over. But other than that, you see the advantage when you do with something like character drivers. What happens is you can do continuous read and you don't need to close the channel, and it is going to supply continuous stream of data. Okay, and if you want to write, again you don't need to close, you can immediately to do write operation, it goes to the kernel space, and you can have a different handler for that write operation and then change the driver. So same thing, you can check the status of the GPIO pin by doing a read operation, you can set the status of the GPIO pin by doing a write operation, and you can do this continuously. Okay, see the advantages you get by phasing out the CFS with a character driver. So hence I'm saying if you are a newcomer, when you read about character drivers, the thing is they are giving a simple example, but architecturally there's a lot to it. Okay, each thing as you read everything, there's a lot to it. Okay, don't just imagine by seeing some introduction and don't conclude I've just done this and then did some test sample code and I know now character drivers. You know character drivers and do what with that? Okay, so what it matters is take this and how you apply it in your architecture, it matters. Okay, if by just knowing that, it doesn't imply anything. Okay, you are still a beginner, you still don't know much of anything. Okay, you just know how to do some kernel module, sample module, or some character driver, it doesn't mean anything. Hence I'm saying if you want to get to the next stage, generally you need to see in a broader aspect of knowing what is happening in the industry, see the updates and see scrutinize any news updates you get. One of the things often I do is I do share if any news update comes. Some updates I share in WhatsApp. I don't do any WhatsApp groups. Generally I share as a WhatsApp update. Most of my students go through, but some updates are meant for some specific students. See, I have many students who are from EC, EEE and stuff, and they happen to work in systems software development. So I do share some updates especially meant for the, viewers like this, and I do have some couple of students who are into that sort of a stream, and they work in extreme kernel type stuff. One may work in some RTOS, one may work in something. So I'm saying, so if it is something specific updates, I do share with some set of subset of my students. Hence I'm saying any news updates you hear or you get anywhere, just scrutinize. If you are a beginner, you should start from there, and then don't underestimate. You just gone through one character driver, now I know character driver. It's not like that. It's just you don't know where to still use this. Actually, you just know what it is. Actually, you don't know what is its true use cases are. So I'm saying in this episode, it's an interesting aspect. So when you architect any kernel modules, say to conclude, when you architect any kernel modules, you can or any kernel driver, so you need to provide certain interfaces to control this driver itself. So in that case, like I mentioned, I am a fan of procfs. Even now, if I do something, most of the times I provide procfs, but this aspect of thinking is important. In a case like GPIO, where you need to continuously set something, reset something, state of LED, state of that GPIO pin, then going with character drivers is a better idea, because you can do continuously, you can do that without any lag. And if you want to be more creative, you can even do something like PWM modulation and stuff. You can do, of course it may not be truly real time, but you can somewhat make it possible. Some sort of a fan controller or something, it doesn't needs anyway accuracy. Okay, you just need to kind of reduce the RPM of the fan, or some sort of a light dimming and stuff like that. It's more useful, it's more viable to do via character drivers, because you can just continuously send a stream of data rather than doing via CFS stuff. Again, if you are using any high level APIs in Python or something, you don't know what it happens. So the thing is, whatever you do in that fancy languages, it is actually passing on to the kernel space, and the kernel is what actually does this operation. Okay, so language doesn't matter, you do in C, C++, Python, Java, of language of your choice, it's just nothing to do with that. The language, whatever you do, it just handovers to the kernel. The kernel is what actually does this operation, the drivers in that kernel actually. So in case if you have anything to discuss like this, be in touch via mail, or if you have any questions on this, post your small Q&A in YouTube comments. Okay, just you can take any samples like this. See, there are various episodes we discuss about character drivers, and some even give some live examples. See, this looks like an interesting page. Let me just bookmark. So that's what, take anything. What is the thing is, you have the character drivers, but you need to see where and all it can be applied. So hence I'm giving you one sample. It's an interesting comment. Hence I encourage, if you post any comments, it should be like some sort of Q&A or something which we can sit and discuss, not just giving feedbacks. I'm not interested reading in that sort of platform either. So be in touch. Okay, hope you enjoyed this show. Take care, have a nice day, bye bye.